Welcome back to Quality Conversations. This episode I'm joined by Adnan Rahić, staff developer at TraceTest.io. If you're interested in OpenTelemetry or distributed testing, this will be an amazing conversation. The folks at TraceTest are doing some really cool stuff and I learned a ton. So as always, my name is Ben Fellows, CEO of Loop QA, and without further ado, Adnan Rahić. Sweet, and we're recording. Adnan, thanks for joining me.
Thank you. Happy to be here.
Cool. So do you mind just giving folks a little bit of your background, kind of what you've been doing, and sort of how you got to this point in your career, specifically when it comes to some of the work around software testing?
For sure. Yeah. Long story short, I was part of a founding team of engineers back, it was almost 10 years ago. We started a startup for basically online education. And I learned a lot from running a startup, and then once it failed miserably, I kind of took all of that knowledge and just started working in developer relations specifically for startups in the startup ecosystem. And right now, it's been more than 6 years I've been doing developer relations. For all of you that don't know what developer relations is, don't worry, I don't know either. I'm joking. No, it's basically PR and marketing for developer-first, developer-focused companies. So let's say the Cypress of the world, or Playwright, or whoever has a testing tool. They need developers who work in marketing to basically educate everybody else on how to use the tool. And that's pretty much the shortest way of explaining what I do. And right now, I am running the developer relations for a startup called TraceTest, which is a quick rundown. It's a way to test your software by using distributed tracing. And that's basically what I'm going to be talking about today. So we're going to talk about observability. We're going to talk about how that ties into OpenTelemetry. So the OpenTelemetry ecosystem, the CNCF, I'm going to say the CNCF tool, OpenTelemetry. We're going to talk about what testing traces means. We're going to talk about everything that you need to know to get started and be efficient with this sort of tooling. So, Ben, I would hope that was a quick enough intro.
No, it was awesome. And I think you touched exactly on where I want to go. So as a sort of forewarning, right, comparatively to some of the other conversations, if you listen to some of my conversations before, I think this is going to be a little bit more technical and terminology heavy. That being said, I've been impressed by your ability to take some of these really complex topics and distill them down. So you're much more the expert at talking about this. How do you start this conversation? How do you get into stuff like OpenTelemetry and distributed tracing? Like, where do you start?
Yeah, that's a great point. So I would say the best thing to look at if you need a really quick 101 intro is the OpenTelemetry website has something called an observability primer. Now, if we have a chat here, so I can just drop a link and I can also just screen share so everybody looking can have a look at it. It is by far the best way to start with the whole observability ecosystem, and then more specifically learning about the OpenTelemetry ecosystem. Now,
cool. Yeah, if you want to screen share, go for it.
Yep. Let me do a screen, and let me do the entire screen, and let me pull up this one. That should be fine. Wonderful.
And then as you pull this up, I think that the main immediate question I have is why care about OpenTelemetry? Like, what does this whole ecosystem bring to you? And I think that's you might be about to get into it right now.
That's a wonderful question. So I'm going to say the more pragmatic people out there are going to say, oh, we already have monitoring metrics log. Why do we need this new concept of something called OpenTelemetry? So many people will argue that you don't really need something like this, but I'm on the other side and I'm arguing that we definitely need a tool like OpenTelemetry. So you remember probably back in the day when somebody was talking about observability in general, we had the three pillars, so-called, of observability. So those were, as you can see here, they covered as well. So there are logs, metrics, and traces. So there are the three pillars of how you can observe your application. But something has slightly changed when you look at observability from a OpenTelemetry standpoint, where more specifically, OpenTelemetry is quite literally just a set of libraries. So it's a framework and a toolkit that lets you export and process signals, as they call them, meaning telemetry data, from your application. As simple as that. It's just a set of libraries. It's a framework that you use. You import the libraries into your code. You use the libraries to create and export telemetry data. And then you can forward that data to any observability backend vendor you're using. So whether you're using Jaeger, Prometheus, Grafana, Datadog, any of the big ones, it doesn't really matter. The point of OpenTelemetry is to standardize this way of exporting and collecting this telemetry data. So you're not using a vendor-specific agent or a vendor-specific framework or toolkit. You're basically using the OpenTelemetry, the open source OpenTelemetry toolkit that the community is supporting. So the CNCF, primarily the CNCF, and the whole community, the open source community, is supporting this one. So that's the point of having OpenTelemetry, a standardized way of doing things, right? So you can standardize the way you're generating your traces, your logs, your metrics, and then getting them, I'm going to say, imported into your Datadog, New Relic, whatever tool you're using. So that's the general point of why we have OpenTelemetry and why we need this uniform and unified system to do these things. Now, what I'm going to be specifically talking about more, so I'm going to say what I'm mostly focused on in this context is going to be distributed tracing. So distributed tracing specifically, to understand it, I would think that the best way of understanding it is to use something like a log. So everybody knows what the log is. It's like since 20 years back, everybody has been using logging. We know what it is. It is just a message that gets emitted from your service, from your app, from your whatever. Logs don't have any context that you can tie together in between different apps. Sure, that's, we know that. Traces do. So the way traces work is that just like we have a log line, traces have spans. And a span is one specific, I'm going to say, message that your application will export. And then a distributed trace is a collection of these spans. Let that sink in.
Yeah, so before we go much more technical, let's just give a quick example of like a real world use case where observability and then subsequently traces would be helpful. And I think that's what we're looking at right here. But can you use it from the perspective of like user, going through the app or something like that for someone who might have a hard time kind of picturing how this would work in practice?
Yeah, and that's exactly what this image is perfect for. Think of it like this. So you have a front-end application that communicates to a back-end application via an API, and then that API is an event-driven system. So you might have a message bus, you might have a, RabbitMQ, a queue, or whatever Kafka, whatever you're using, that might then interact with a payment gateway that's a separate service altogether, that then needs to send another message, and then you need a third system or a third service polling for this particular message. So the best way of thinking of it is that if you have a highly interdependent, event-driven, asynchronous system, tracing is the only real way you can troubleshoot what is going wrong if something goes wrong. Because of its async nature, logs don't really, you have no context in between what's happening. With tracing, you do. So I would think that's the best way to think about tracing per se.
Awesome. And we're going to get into this, right? But one of the first questions I had when I was talking to you a little bit about this is, how hard is it to implement something like this? Like where does that go? But before we do that, can you set the stage for how this might be relevant to a QA audience? I think that for me, it makes a lot of sense, but can you maybe talk a little bit briefly about, for folks that are in QA positions and stuff like that, why do they care about what you're showing so far?
Yeah, that's a great question. So from first and foremost, from a DevOps standpoint, I'm going to say the SREs are the ones that mostly benefit from tracing in production. So they're the ones that have to wake up in the middle of the night and go, oh, okay, so something broke. Let me look at the traces, try figuring out exactly what part of the system broke. And tracing is very good in that aspect. But that's all after the fact, production troubleshooting, figuring out why something broke after it actually broke. From the QA perspective, and to some extent to the developer perspective as well, we want to push this process to the left. So on the screen, it's like, no, this way. Yeah. So we want to push it to the left as much as possible, where we don't want to put all of the load on the SREs and the DevOps team to figure out what happened. We want to use these traces proactively. So before the code reaches production, we want to use the traces to set up validations for our software, so our apps. So that's something that TraceTest is built upon, where we're focusing on something called, we're coining it, but let's call it test observability. So when you actually run a test, you can see all of these traces that your system is generating, and then you can also, because of this, pinpoint exactly when something goes wrong. You can quite literally build your test cases on the trace itself. So that is pretty magical. If we go back to this example, I can go in and say, this asynchronous payment gateway that gets triggered by whoever knows which service, I don't really know because it's all behind an API and the API is asynchronous. I can go in and say, I want to tag that particular service. I want to set an assertion on that particular service, and I want it always to return status code 200. I want it to always have message XYZ, whatever. I want it to always be quicker than 200 milliseconds, whatever your test case may be. This is the data the telemetry exposes to you, and that's what's cool here, because any data you get from your system that gets exposed or exported by the telemetry or by OpenTelemetry, you can run tests on that, and that's the I'm going to say the power play, or the cool thing about TraceTest is you're using the trace from your system to run tests. There's no faking, mocking. There's no trying to figure out what your system is doing. You're getting everything right away. So from a QA perspective, if I want to create a test, or even more specifically, if I'm running a test and the test fails, I'm not going to just send this over to my devs and say, yo, this is not working. I'm actually going to tell them this is exactly what's not working. So the turnaround for actually figuring out what's wrong is so much quicker because you have a trace and because you have a test specifically on the happy path of the trace.
So just to kind of repeat back what you said, right? So let's say that you're writing a Playwright end-to-end test, right? And it's, doing all of the UX UI stuff. Basically what you're saying is that all of the observability components that go up and down the stack as that test happens, you can then make assertions against all of those. And when that test fails, which it might fail at some point, rather than just having to rely on the Playwright report or the Playwright test file or something like to that regard, you know exactly where in the stack it failed and at what point, and you have that visibility. Is that kind of a fair characterization if I repeated it back to you?
Exactly. So you're quite literally getting true end-to-end testing. So you can start your test or trigger your test from Playwright, which basically goes through the UI and then triggers buttons, APIs, or whatever you choose your test to do. You will then also pick up everything your backend did, including databases, asynchronous processes, everything, because all of that data will get exported by OpenTelemetry. So you get that data in your trace. So you're basically getting a full end-to-end overview of what that particular transaction did, including the clicks on the front end, including the APIs that were triggered, everything back to the database or whatever else happened in the backend.
So then why doesn't every company in the world have something like this, right? Like there has to be a reason why, not every company is doing this. I'm curious, and I sort of know the answer because we've talked, but to ask you, right, like why isn't every company in the world doing something like this that has this level of observability?
They're just not as awesome as I'm joking. So one of the first thing is that distributed tracing hasn't been adopted enough or mature enough for it to be ready for the public yet. So OpenTelemetry just this year, it was at KubeCon a couple of months ago. They announced that their libraries are all stable. So it's just this year, all of our libraries are stable and ready for production use. So it's not really, it wasn't really there yet. Now you can say, it was always, I'm going to say, me 2 years ago, I was hyping up OpenTelemetry as, this is the tool of the future. Today, it's the tool of today. You know, so it's getting to that point now where more people are adopting it, and that's why we need something like this to actually also validate that your traces are good, and also validate that your highly complicated asynchronous event-driven systems are basically doing what you want them to do. So that's why we built TraceTest.
So there is an order of operations here that we're talking about, right? First, adopt something like OpenTelemetry, or specifically OpenTelemetry, then get comfortable with the observability and all the components of that, and then what you're talking about is being able to layer something like TraceTest on top of that, because TraceTest, just to state the obvious, doesn't work without OpenTelemetry underneath it. That's sort of a...
Correct.
Okay, great.
Yeah.
So can OpenTelemetry be adopted by organizations that might have been already developing a product for 5-10 years, or is it really important to only adopt it at the very beginning of the project? Like where does an organization listening to this and going, wow, this sounds amazing, like what's that adoption process look like?
That's a great question. So I'm not going to sugarcoat it. It all depends on the scale of your organization. If your organization is massive, everything is gonna be a problem, of course. But to be very realistic, we have customers that have thousands of developers that did not have OpenTelemetry from the get-go when they started to develop their products, and it took them. So one of our customers, it took them 3 to 6 months to implement it. The implementation never stops. You just continuously adding telemetry to your system. But they were at the state where they were ready to use it in production and use it with TraceTest in the matter of 3 or so months. But then we have another customer where it took up to a year to get them going. So again, it's a very relative to how your organization is structured. But if you're a small shop, if you're a startup, if you have less than, I'm going to say, 50 people in your team or 50 devs, it's not hard. It's not hard at all. And I will showcase both a super simple setup of how to use OpenTelemetry and to use TraceTest, but I'll also showcase a bit more of a complicated setup with Playwright as well, so you can see that. But
yeah, let's dive into both those demos if that's cool with you.
Yeah, for sure. Now, because we have a more QA focused audience right now, I do want to first just outline what we're going to be explaining. So you can also check this out if you jump over to the TraceTest documentation. You go to the recipes and you pick this little Node.js with OpenTelemetry sample. It's a stupid simple sample. I can even put up the code itself. It is quite literally just an app.js file. Let me zoom in a bit more so you can see it. It's quite literally just a app.js, Node.js file with a bit of Express. So it's just an API. There's nothing really happening here. But what I do want to show is the code itself, how you do actually add OpenTelemetry tracing to a system like this. And this is it, 16 lines. And it just works. It's no bigger or no harder than using any custom logger or whatever the loggers nowadays people use for Node.js. This is it. You're importing your OpenTelemetry libraries. You're importing obviously .env because that's what I need for my sample, and then you're instantiating and running the SDK. This is not complicated at all. The packages you really do need are, there are 5 or so packages. They're all OpenTelemetry specific. You even get something called auto instrumentation. So every single library for OpenTelemetry, they have something called auto instrumentation as well, where you quite literally just install and instantiate the auto instrumentation library, and it will start generating traces without you editing code at all. So that's, if you remember APM of a couple of years ago, you just kind of magically works and figures out the performance of your APIs. This is basically the same thing, but better.
Awesome.
And that's all you really need. And now I'm taking the liberty of just running this little app here in a Docker here. Yeah, I'm going to show you the Docker file as well. It's just a little like Docker app. Now, and once I actually do run it and I trigger, let me show you, trigger a curl and just do like that. This is going to return hello world, fine. But also what's more important is because I'm using this little, I'm going to say console span exporter, this is just going to output all of the traces to my console. So just like doing a console log with logs, just do docker compose like that, logs f, and this is it. So the JSON output you can see here, this is quite literally the OpenTelemetry trace that we're getting out. And you can see service name, telemetry SDK, and what's more important, you can specifically see attributes here that define what your API is doing. So you can see here's the route, here's the query, the middleware I'm using, the version, everything. So this is quite literally a context-connected log. So if I have an API talking to another API, it's all going to be within this JSON object. And this is, this is not really, this is underwhelming if you're looking at it from the console like this. And that's why I'm going to be, I'm going to take it a step further and be a bit more serious. And that's why I'm going to pull in TraceTest as well, so you can see what all that looks like in a graphical interface, but also how to run tests against it. So
and then ultimately, right, not to jump the gun here, right, but what we're talking about then is generating these logs, which are great from an observability perspective. I always stumble on that. But then the next step would be being able to assert against these logs, essentially, correct? That's kind of not to spoil the surprise at the end, but that's where we're going here.
Exactly, yeah. So all of this data you saw in the console, first we're going to just visualize it so I know exactly what's happening. So anybody that looks at this particular API request can see exactly what happened. So basically you can see all of the telemetry that API request generated. And then you can also assert on all of the values. So the attributes I was just showing, so all of these attributes, you can assert on these. You can say, I want my URL to be equal to this. I want my host to be equal to that. I want my method to be this. So basically you can create so detailed assertions, amazingly detailed assertions based on real data. So you don't really have to mock anything. So you can basically create an assertion on an API that's three APIs downstream without mocking anything, and it's freaking cool.
Yeah, that is
just
awesome.
To showcase that, let me just pull this in. So just a quick overview so you know what's happening. The TraceTest agent here is it's just a little piece of software that runs as part of your network. So wherever you're running your apps, it needs to be on the same network just so we can trigger tests. It's just, like any other tool, you need to be on the same network as your app to actually run a test against the app itself. I've also pulled in, the only thing you really need is an API key for for your TraceTest account. It's super simple. You just go into your account, you get it, and that is quite literally it. Now, if you go in here and just save that up, and now one thing that I might explain that it's important is in this trace setup, we can't use the console exporter anymore. We need to use something called an OTLP exporter. So the OTLP exporter is using something called the OTLP protocol, so the basically OpenTelemetry line protocol, and that is the OpenTelemetry specific protocol to send traces, metrics, and logs from your apps to whatever tracing backend you're using.
Let me ask you this then, just to pause for 2 seconds. Would you say that someone, in order to have success with this testing tool, probably needs to have a pretty intimate understanding of OpenTelemetry, right? Because like what you just said, I'm sure it's very learnable, right? But it's some of those terms I've never heard before, right? So in order to have success with TraceTest, you probably have to start with OpenTelemetry in some capacity. I mean, to just teach yourself that from a learning perspective and making sure, or do you feel like those are not mutually exclusive? I'm just curious your perspective there.
It depends on your role. I'm going to be very specific and say that it heavily depends on your role within the team. So if you're in a DevOps team, I'm going to say you have both SREs, you have developers, and you have testers. So that's your basic setup of a DevOps team. If you're solely doing Q&A, you probably don't need to know anything about the setup itself, per se. You don't really care about the setup. You care about the data that the trace, or basically the telemetry data that your system is exporting as a distributed trace. But if you're more on the development side or more on the DevOps side, then definitely yes. So this is something that you will need to know, but you definitely don't need to be a master. Like I'm not that smart. Like this is like I'm kind of okay. Like I'm an average engineer at best, right? And if I can figure this out, it's easy. Like it's simple. It's not that hard. One thing that's slightly a headache, I'm going to be very honest, is the OpenTelemetry documentation is not as good as it could be. So that is something that I've specifically tried pushing the contributors on a bit more, and specifically pushing myself to contribute more to the documentation. Just because things like these, they're not really explained in that much detail in the documentation itself. They're more explained in the examples and in the GitHub examples, the code examples that you will be using and looking at, which is a shame. That's definitely a shame.
Awesome. Yeah, thank you for that context. It was just, it occurred to me as you started to drop some terms that I had never heard before. Like, I wonder what that curve is. So knowing that we probably only have 5 to 8 minutes-ish left here, let's move on, and I'll stop interrupting you.
Yeah, definitely. Let me just save this up and just rerun our little Docker example here. And now what's going to happen now is, because we have this, we have the TraceTest agent included in our little setup, we can jump over to our TraceTest app right here. We can jump into to our little app here and let's just validate that it's all running fine. Probably is. Yeah, that's the problem. I need to sign in. Yeah, that might be good if I sign in. There we go. Now it works. And let me just run a little test here that I've pre-prepared for us. It's the same thing. I'm running a GET request against the app on port 8080. Same thing. I'm getting my little hello world, just as I did with, actually, let me zoom in. Same as I did with the curl. And let me check the test here. So this is what we get. Probably this is a bit easier from the get-go. So this is what we get on our distributed trace. So this is the visual representation of the JSON output I was showing a moment ago. This looks a lot better. And what's cool here is that if I want to look at the attributes specifically, I click on, let's say, the GET request, and these are all of the attributes I was showing in the console. If I want to run a test on something, let me go ahead and say create test spec. Yep, I want my host to be equal to app 8080. Save that, and I get a test. Save it up. I have my assertions. And I can do this with basically anything I want. Let me go into, I can do the request handler. I want the request handler to always have the route, which is /, and I'm going to do, it should be /, and that's it. And this is how easy it is to create your test specs. You don't have to mock anything out. You don't have to write 90% of your code just to make the test do something. And then you're basically spending 5 minutes writing the assertions and then 2 days to figure out how to actually make your test run a test, right? It's so frustrating. And that's coming from somebody, I've been writing TDD. So for my startup, so many years ago, we were writing TDD with Mocha, Chai, whatever Node.js libraries that we were using back then, and it was a freaking pain in the, it was so bad. It's basically 2 days of writing the setup for the test, and then 5 minutes of actually writing it should be equal to this. Right? It's horribly time consuming, and you're not really getting a lot of value back from it.
So to jump in for 2 seconds, just to echo this point. So one of the things, for example, that when we start engagements that we face is that people will be like, okay, we want to add more unit tests, right? And then we go look at the code, and the code's not easily unit testable. And there's a lot of situations where, you might end up having to mock 4 or 5 different functions just to quote unquote unit test something, which is basically an integration test, but we're getting into all the terminology components of it. What basically you're implying here is that because you have the ability to actually assert against every step of the code, you can almost just combine a boatload of different tests all at once. That's sort of what we're saying here.
Exactly. So you are literally doing true end-to-end testing across everything with one test. And if that's not cool, like, bro, what do you want me to do? You know, like, what can I do?
All right, real world example. Unless you have anything else you want to cover here?
Let me show you the Playwright real world example now. Pulling up this one first. So this is just a quick show. This is the actual example I'll be showing. I'll just drop it here in the chat for people to follow up after the call. And so this is what happens with when you're using Playwright. Let me just do a quick rundown on the app itself. We have a React app. We have the Node.js API that communicates with the RabbitMQ that then triggers a worker, then talks to Redis, talks to Postgres, and then primarily talks to an external API that I don't manage. So how would you test this? Like, this would be a nightmare to figure out how to test. You'd have to test this one with a specific test, and then you'd have to test the database to validate if the worker is working, because you can't really test the worker because you don't know when it gets triggered by RabbitMQ. Like, it's impossible. Like, it's horrible. You have to have 7 different tests to figure out whether this one import flow actually works or not. Correct me if I'm wrong.
No, that sounds about accurate. I mean,
yeah,
some interesting nuanced arguments in there, but yes, for the sake of this, sounds accurate. We'll save that for over a beer.
Yeah, so it's painful, right? And the UI, you know, shows that. If I want to add a Pokemon, let's say 6, because I think Charizard is awesome. So this is going to trigger the queue. I'm going to wait for some seconds until the database is updated, and then the React is going to figure out, because of an event that happens, that the front end has to reload or whatever it has to do because, you know, whatever, I broke this. And so it's a very, very complicated process. Now, let me go ahead and run this sample specifically so you can see exactly what I'm talking about. Pull up this one. Let me go ahead and change my org to this one, and let me just go in and look at the tests. Now, let me see if everything works as it should. This is the demo gods not being nice to me.
Power of live demos. If there's one thing that's predictable in the world.
I am trying my best, okay? One second, let me pull up.
No, take your time, man.
Look at the tests. And there we go. And we should be good. Let me just jump over here and just validate that it's working as it should. Wonderful. There we go. Yeah, app is running. So now, what I want to show you now, if I jump back over to the code, the way we integrate with Playwright is pretty cool, because if you look at this specific code, so it's a home.spec.ts, it's like just a basic Playwright test. If you look at the way how we integrate it, it's basically, it looks like any other Playwright test. We have one test here, we have one test here, then we have a final test here. Pretty normal looking. What TraceTest does is we wrap everything TraceTest related in these lifecycle hooks. So we have a before all, before each, and an after all. What we do, we also pull in the test definition from TraceTest, and we pull in some modules that we need to actually run the test itself. And this is pretty magical, because this TraceTest definition, so the test definition, you pull that in from your app. So if let me just open any test so you can see what it looks like. You can pull that in from your Automate tab. Just copy it. So all of the tests I create in the UI, I can just copy the test here, and I can get the exact same test definition that I have in the UI to run via whatever CI or whatever integration I want. So now if I show you what that would look like, the way I trigger this, very simple. Just go in and say npm run Playwright, and this is going to start my Playwright tests. It's going to every time. So let me go back here. Every time before every single one of my Playwright tests, it's going to reach out to TraceTest. It's going to basically enhance the Playwright test with a trace-based test. So it's going to reach out to TraceTest, get the traces from your system, and then it's going to start running those assertions that I was explaining a moment ago after your Playwright test. So you're basically getting, so these all passed perfectly fine. Let me show you what that would look like here. Do the import. So this was 30 seconds ago. Wonderful. And this was what that would look like. I'm basically getting a full overview. Let me just close it, zoom in a tiny bit. I'm getting a full overview of exactly everything that happened for this Playwright test. Everything that happened in my app. So I'm getting all of the front-end clicks. I'm getting the API requests that were triggered from clicking a button in the front end. I'm getting the database requests. So this particular get Pokemon API triggered something in the database. So I'm getting that as well. I'm also validating, so this initial import, I'm validating that it went well because it communicated with the message queue. And then I'm also checking the external API, and then I'm checking the database here at the bottom as well. So I am quite literally running a Playwright test, and I'm getting everything back. So usually when you run Playwright, as you said at the beginning, you have visibility up until the API, and then you get a report, and then you kind of do a guessing game and trying to figure out what happened after the API and what went wrong. Now you know.
Yeah, I mean, it's super impressive. And I'm imagining that if you were to do a demo or something were to fail, it would probably highlight whatever, box it specifically fails, and you'd be able to immediately kind of understand where along the route that you got that failure. Is that kind of a fair guess?
Exactly. So that's one of our main thoughts behind the notion of test observability, is that we want QAs to have visibility as well. So if you're a QA, you're running these tests, you want to go in and see what exactly went wrong. So let's say in this particular test case, we have something called, we want all of our database spans to return in less than 2 seconds. So if we change this to whatever, 100 milliseconds, we can see exactly what went wrong. So if we just save this again and look at it, now we can see, we get this one is 300, that's not good. We get this one, that's 126, okay, also not good. So now you know exactly what's happening, and you know specifically which service it's happening in.
Yeah,
and that's pretty cool.
It's really cool. So we're at 37 minutes now, which I don't think I gave you a heads up that I was going to try to keep it on the sort of 35 minutes range. So not to put too much time pressure on you, but if you had 2 more minutes to kind of explain any points that you feel like you haven't touched so far in this conversation and demo, what would be the last 2 minutes? Where would you spend it?
I think I would jump back into here. So one thing that the team has been pretty adamant on is trying to group tests in a logical, or specifically test runs in a very logical way. Because when let's say go back to the Playwright test itself, Playwright does something cool where they do this, just open, and they open this browser window, and then you can basically see everything through this little window if you run a test. And this is really cool because they're grouped in a logical way. The team wanted to do something similar by doing it in the UI here as well. So basically, whenever you're triggering a set of tests with any integration, let's say in this case it's a Playwright integration, it's going to group it all together, and it's going to output everything in one pane, so you can check out exactly what's happening. And I'm super happy with this because it just makes it so much simpler. If you have a test suite with, I don't know, 20, 50 tests that are run in a group, or they run because they have the same context, or they run because of whatever structure you have, this is so cool. And this is, I don't know, I think that's really cool. But on a general note, definitely OpenTelemetry is the tool of today if you want to start with observability. TraceTest is cool if you're looking into testing your traces and testing your system based on your tracing. But definitely start with the OpenTelemetry part, and then you can gradually move into this.
Yeah. Okay. So To summarize, guys, and I know you literally just wrapped it up. Yeah, check out OpenTelemetry. Once you guys get used to that, check out and playing around with the observability. Please feel free to check out TraceTest. I have been really impressed talking to the guys and the team behind it, really enjoying learning more about just this whole field for myself. Adnan, thank you for joining me today. I really appreciate it. Is there a blog or anything like that you want to shout out or have people check out?
Yeah, for sure. You could just drop into tracetest.io/blog. You can jump in there. Basically, all of the tutorials and guides that many of which I already spoke about today, you can just pick up on that here. You can check out all educational content here, and yeah, you can check out YouTube as well if you want. But yeah, probably just better to go to the blog.
All right. Well, thanks for joining me today. I really appreciate it.
Thank you for the invite, and I had a lot of fun. So yeah, thank you.
All right. Talk soon, everyone.